Hello dear student, welcome to my YouTube channel. In this video we will see ozonolysis of alkene. So like the video and subscribe the channel. Now the next step, next reaction that we will see, that is ozonolysis. Ozonolysis is an organic reaction where unsaturated bonds of an alkene, alkynes or azo compounds are cleaved with the ozone. Here we will take only an examples of an alkene, how alkene it reacts. It will form an ozonide, and once the ozonide it has been formed by reacting with an ozone, we will get a carbonyl compound as our product. So whatever will the R substituent over here, so that carbonyl type of an product we will get at the end. Carbonyl means we will get an ketone products after formation of this ozonide. Ozonide, it is an intermediate compound which has been formed, and after reduction of this ozonide we will get a carbonyl compound. For that purpose one should know the mechanism of this. See, in the mechanism of an alkene, when alkene it has been added to an O3 structure, it is quite unstable, right? It is having an electron deficient carbon, electron deficient oxygen, and electron rich oxygen, and also it is having a stable oxygen. So electron, the pi bond between carbon it will break, and it will donate the electron towards one of an oxygen, and after that the electron rich carbon, which is electron rich, so that will donate the lone pair of electron towards the carbon. And at that time, at the same time, when the pi bond it is breaking and giving the electron pair towards the oxygen, the pi bond between oxygen and oxygen it will break, and it will now form a one of a stable structure in the middle. So that stable structure, now you can see that all oxygens they are having two lone pair of electron. One of the lone pair of electron it has been attached with the carbon, it has been utilized for the bond formation between carbon and oxygen, sigma bond has been formed, and one lone pair it has come from this pi bond breaking of an oxygen, and it has been shifted on the middle oxygen. And now the pi bond which was been between the carbon and carbon, so it has broken and it has given a lone pair of electron towards the oxygen. So this, it has formed a new bond. Now this monoozonide, it gives a fragment. It gives a fragment by breaking. So it gives a fragment by breaking in what sense? That the carbon bond it will break and it will give the fragments. And once it gives a fragment, the carbon bond it will break, and sequentially after that the oxygen bond it will break, and it will give electron towards the oxygen. So that is why you can see there are three lone pair of electrons on this, and one of the lone pair of electron again it has been utilized for the formation of a pi bond between carbon and oxygen. And this oxygen it becomes an electron deficient, because now it is having an only one lone pair of electron. As such, it should have an two lone pair of electrons. So these fragments, so one is carbonyl fragment and second one is a Zwitter ion. It is also said to be a Zwitter ion, and they will again recombine. So they will recombine now in a different manner. That electron rich oxygen, they will donate the electron towards the carbon, and the pi bond between carbon and oxygen it will break, and it will give the electron towards the electron deficient carbon, and at the same time the pi bond between oxygen and carbon it will break, and it will give the electron towards the oxygen. And once they will combine, they will form an ozonide. Now you can see that the pi bond it was broken, and it has given the electron towards the carbon, which has formed a new bond, and the oxygen it has given electron towards the carbon, it has formed a new bond. Now it's a stable structure once again. It is more stable than this molozonide, and we have now got an ozonide structure. And the bond between the carbon and oxygen pi bond it has been broken, and it has shifted the electron towards an oxygen. And after reduction with an dimethyl sulfide, we will get a carbonyl compounds, or we will get a ketone compounds. After successful reduction, we will get these two compounds of an ketones. This was about the mechanism of an ozonolysis. Thank you for watching the video. If you are having any doubts, you can comment me in the comment box section. I will surely answer it.